Okay, so on part B here is where we left off at. Is that correct? So in part B, we were talking about your stating the value of your where the X is a maximum or a local minimum. Key thing is local. So when you're looking at local, you're just saying, where do I increase and decrease? So remember, for a maximum, you increase, then you decrease. For a local minimum, it's where you decrease, then you increase, okay? That's all you're looking for, is where does this take place? And it's saying X, and remember, X max marks the spot. So it only wants to know the X value of where that happens, okay? So maximum, at what point in my graph does it increase, then it decreases?
That literally says 5.
So it's just at X equal. So my max is at X equals 0. Does that make sense? Okay. It says, where does the minimum occur? And again, where is X only? And my min, I'm looking for, when do I decrease, then increase? Where does this happen at? X and some change, right? It's like, so at this point, if I can't say exactly the value, like here, like, what did you say you would have to do, Lydia? You have to graph it. So you would then pull out your graphing and do your max and min to find that location, okay? So I will tell you right now, I already did the graphing, and it's going to be at X equals -2/10 and at X equals +2 85/100. Okay. So when you can't read it from the graph, even if the graph is provided, you have to resort to actually putting the function in the calculator. Okay. When it says identify local value, value is referring to what is it? What means your Y? So when I'm asking what is the value, I'm asking for the Y. So what is my local max value? 0. So for the max, the Y equals 0. That's my local max. Key thing. It's not my absolute, because clearly it goes on forever, right? Now, for the mins, I would have to resort back to what? Reference back to the calculator, because can I tell exactly where it's at? No, but if I use the calculator, it's going to tell me that my min happens at -3 63/100. And it happens at -8 197/100. Out of these two, because my graph does not go on to negative infinity, this one is what we would call our absolute minimum. It's because it's our lowest point of our graph. Does that make sense? That's why it's our absolute minimum. It's just local. It's just relative or local. Because of the infinity, the fact that it goes forever to positive infinity. Okay. This is generally what you're doing on your graphs that you have for by Friday. Okay. You need to be able to go through and analyze the attributes of the graph. Got it? Okay. The last thing we're going to talk about for this section is your, what is it? Max and min value, your absolutes. Okay. So you notice how I set the word absolute. Absolute can also, and depending on the textbook, you may see it as absolute or global extrema. And remember, extrema is just referring to your maximums and your minimums, okay, of a graph. So when you're looking for your absolute, you're saying this is the highest or the lowest points that my graph will go. Does that make sense? So looking at this example of this graph here, if I asked you for the absolute maximum, where is my absolute maximum? At 1. It's at X equals 1. And what is the value there? 3. We all agree? The value is the Y. The where is the X. X marks the spot. The value is the what? The Y. When you're identifying a min or max, you won't just put an ordered pair. You would put where it is or what it is. And- So the key thing is how the question is being asked. If I can, in any form of synonym of asking me where something is, I'm asking you for the X. If I'm asking you for the value, the amount, the anything, the what, I'm asking you for your Y. X marks the spot, Y is why you're there. Okay? Make sense? All right, so we understand absolute minimum for this graph is? -5. At -3, we have -5. Okay, that's how absolutes work. And we know there are absolute because we do not go any lower than those values. Agreed? All right, questions, comments, or concerns? Perfect.